before we will see the what is meant by energy of the signal and what is meant by power of the signal, and neither energy nor power of a signal, and we will see some problems as well as the some conclusions based on the energy of the signal, power of the signal, and neither energy nor power of the signal. Now let's move on to the next concept, that will be the what is meant by system. What will be the different type of systems will be present in this lecture, we will see in detail. First thing, in the first class I will be tell you what is meant by signal and what is meant by system. Okay, in the before classes we will see different type of signals from the basic level, that means continuous signals and as well as the discrete signals. Now let's move on to the what is meant by system. Here you can see many real systems are built as interconnections of subsystems. So for example, if you take the example, so this be the input, if you given to the some system, here you will get the output. For example, this be the amplifier means, so if you give the input like this, you will get an amplified output like this. Okay, so here it will take the input as this signal, and here some process is done, then you will get an output with the amplified signal. This was the perfect example for the system. And here also we can see different type of interconnections will be there, how that signal will be processing and what will be the different type of interconnections we can see in this class. Okay, for example, the perfect example for the system be the first be the amplifier. Next, for example, if you see example, audio system, right? Audio system. In the audio system you can see there will be an radio receiver, tape deck with amplifier, and speakers, right? And speakers. Okay, whether it may be one speaker or one or more speakers. Why I am taking this be the example means, in the daily life you can see this be the example. This will be the perfect example. Okay, now let's see what will be the different type of interconnections will be there for these systems. We can see the first interconnection be the series or cascade interconnection, and the second be the parallel interconnection, okay. Third be the series parallel interconnection, and the final be the feedback interconnection. Okay, now let's see the what will be the block diagram for the series or cascade interconnection. So series or cascade interconnection block diagram be like this. So if I want to give the input, okay, and if I given to the system, if I given to the system 1 and here system 2, there you will get your output. Okay, that means initially what we have to do, we are giving the input here and some processing is done in the system 1 and that output is given to the input as system 2. Okay, there you will get an output. That type of interconnection is said to be the series or cascade interconnection. You already know from the discrete or the continuous systems how we can represent the continuous and the discrete systems. For example, if you see this be the continuous and another that will be the discrete. Okay, for example, if you give the excitation to the system, you will get an response. Okay, for example, if you represented the discontinuous means, have you represented the continuous in terms of systems? Continuous can be represented with x of t, right? Continuous be represented with x of t, and this discrete can be represented with x of n. Okay, so here for the continuous, if you take this be the input, this be the system, and this be the output. So here input be the x of t, you will get an output be the y of t. Okay, don't worry about that what will be there in this black box. That means what will be the things will be there in this system. Don't worry about that. We just have to need, you have to just give the input in the system. In the system some processing will be done to get your appropriate output. That output be the y of t. For example, if you want to represent it in the discrete, how you can represent it? Here also this be the input, here this will be the system, and here this be the output. Okay, here we can represent it with x of n. X of n, you will get an output be the y of n. Output be the y of n. Okay, this was the basic for the continuous as well as the discrete, and here this for the series or cascade interconnection. Okay, now let's see the what will happen if we represented the parallel interconnection. Parallel interconnection. Parallel interconnection. The block diagram will look like this. So this be the input, and here, okay, let's draw somewhat big. parallel interconnection. Okay, here you can see this be the input. Here you will give into the system 1, and here this be the system 2, and here this be the system 3. Okay, this be the summer. Okay, here you will get an output. Okay, this was the block diagram for the parallel interconnection. Here also we will give the input here, and one go for the system 1 and another go for the system 3. And here whatever the output we will be getting here and whatever the output getting here, just add up. This will be the summer here. That means it will just add up and given to the output. Here you will get the required summer output. That means adding output. Okay, the perfect example for this interconnection, parallel interconnection, be the your microphone. Your microphone is connected with the amplifier as well as the speakers, right? Multiple devices. So example, microphone with amplifier or amplifiers or on speakers. Amplifiers and speakers. Okay, next we will see the what will be the series parallel interconnection. Next be the series parallel interconnection. Okay, let's see the block diagram for this series parallel interconnection. That be the, so here this be the input. Okay, here this be the system 1 and that output given to the input as system 2, and here this be the system 3, and here we have to given the summer. Okay, that whatever the output we are getting, that will be given to the another system, that will be the system 4. There you will take the output. This will be the system 4, and here this be the output. Okay, this was the block diagram for the series parallel interconnection. Last we will see the feedback interconnection. Last we will see the feedback interconnection. Okay, this feedback interconnection you all are very familiar with this. So here if you given the input, okay, so here you will given the system 1 here you will get an output, and here this be the system 2. Okay, this was the block diagram for the feedback interconnection, right? This diagram you already see in the many times in the control systems, right? That means here if you give the input here, this will be the summer, and here this will be the system 1. Whatever your output we are getting at the system 1, that will be given here. Here this will be the system 2, and here you will get another. Here you can check whether it may be check the error, right? So that means the C of S divided by R of S. There you will get the check the error, how much error will be present. In the most of the recent technologies and as well as the recent modern era things, we are using this feedback type of interconnections. Okay, this was the perfect example for the feedback interconnection. And next we will see the what will be the different type of systems will be there in our signal systems. The major we are concentrate on the one type of system. In the next class we will see what will be the type of system in detail. From that, the main properties we will get to encounter all of those things. If you really like this video, please like my video, share my video, as well as the subscribe to my YouTube channel. Thank you.